Oh my God! I just broke my finger.
Okay, class.
Oh my God! I broke my finger. Mister, I can see my bones in my finger.
Bones.
Yeah, I broke it. Oh my God! Shit! Wait.
Broke it.
Yeah.
Good afternoon, sir.
Good afternoon. Yeah.
Good luck, Ahmed.
Oh, my
So
fingers.
what is really happening, sir? I don't know.
What happened? Fall down.
No, sir, like
No, Ahmed broke his finger.
Oh, yes. How? You fall down?
Oh shit! Wait. How can I put my bones inside again?
I have no idea.
sir, they have sent us the declaration form already, sir. Like
Yeah. So now there is definitely there is a mock.
online.
It's not a face-to-face. It's a online mock. And yeah, you have several choice, right? Either you default or you take this result. This result based on online mock, based on your previous exam, and we have to rank you. I think your class 15 students. Let's say if you rank you 15 students, after we rank you, let's say you and I think the top 3 or 4 maybe go for A, I think.
But then, no, mister, you need to rank them according to the grade. Like, you give 5 students A, then you rank 5 students for A. Then you rank, for example, 6 students for B, you give them the rank for B. It's not like rank them overall.
Yeah, we are waiting for the, yeah, correct, like that. Yeah, we haven't got the detail yet. But still, we are waiting for we will have a meeting with the scholars. I mean, the college to explain us further. So you mean what? Like those who are A candidate, rank them who's supposed to be the first, who's supposed to be the next, who's supposed to be the B, and who's.
So maybe the A also you can determine like the highest A and the lowest A, like that, based on that, right, sir?
Yeah, correct. Like that, yeah.
It's like some like maybe one person get 86, another person get 84, so 86 goes first, then the second will be 84, then so on, like that, right, sir?
Yeah, correct. Based on your online test and on your I don't know what are the things need to be considered. They will tell us. I think most probably they're going to follow your A level result, your actual A level result also, your AS result,
Yeah.
The actual AS result going to be the important criteria to be considered. And next is your online test, which is going to be held later. These two. Okay.
So let's say, so for AS I got AS maths I got B, but online test I got A, so then most probably what they'll give me, sir?
So depend on your ranking also, ranking in the class.
Oh.
What I believe, as I said before, the Cambridge only going to give top 10%, 20% A, top 20% only A. Okay, when they give that top 20%, how they're going to give? I think they will consider the ranking. Second, they will consider the region also. I think region, because they have a lot of statistics in their hand. Asians do normally better than the Europes.
Yeah.
So Asians, they'll check the statistic. I believe they should check the statistic. If the statistics, Asia is like 40% average get A, they should give us like 40%. Okay, they can't give you like treat Asia with other part of the world equally, because they have to check the statistic. Okay, the previous statistics, which region got a lot of A's, how many percent? They will follow that. I think these are the 2 criteria. I think. Yeah, no choice. Like your batch is like, I don't know, fortunate or unfortunate. It's all depends when the result comes up. Hope the university's intakes are quite linear about it. That is, you have some argument to tell them that it's not fair and so on. Yeah. So yeah, okay. So are we supposed to do what today?
Continue with paper 41, sir.
Paper 41,
No, sorry. October, November 42.
October, November 42. Okay, we go to 42.
Because yesterday we left halfway, but sir.
Hold on, man. 43. This 43. This 42. Let me check 42. Okay, 42. Okay. Which question? Yeah, this question. Still have any
Yeah,
questions?
sir. You told you'll get back to me, sir.
This question is actually they're asking from muscle to fat, from fat to muscle, from fat to muscle, right?
Yeah.
Yes.
Determine the vector intensity entering the layer of fat.
Question D, sir. Yes, that's the one.
To the layer. Hold on. Determine the fraction of intensity entering the layer of fat that is transmitting. Yeah, correct. We follow the image. This image lah. They're asking what is this intensity ratio I naught. Okay. Of course, when it enter, partially reflected, partially transmitted, then it goes straight, and finally this intensity. Let's say the one reflected is I1, the one transmitted here I2, and the one reaching here is I3. They're asking what? I3 or I0? I3 or I0, right? They're asking for the I3 over I0. Let me check. I3 over I0. The wording is quite confusing. I use to determine the fraction of intensity entering the layer of fat that is transmitting through the layer of muscle. Determine the fraction of intensity entering the layer of fat that is transmitting through the layer of. Yeah, the I3 over I0. Asking for I3 to the I0.
So why is it I2 is actually what, sir?
I2 is the one transmitted after passes the fat and muscle boundary. That means what you have to do now? You have to do how I3 related to I0. I3, how many absorption? One absorption.
One
absorption. The E what? E 0.45 what?
negative 0.45 with the coefficient.
The fat one, right? The fat one, the fat coefficient. Then times with what? This region, you take alpha or 1 minus alpha for the I2.
1 minus alpha.
So you take 1 minus alpha, then times with this absorption, which is E.
So there's basically 2 absorptions and 1 reflection.
2 absorption, 1 reflection. Yeah, correct. But reflection, you could take the reflection one, the one transmitted. So 1 minus alpha to be used. That's the working, right? So from here to here, the wording is confusing.
Yeah. Oh, so no wonder they times with those.
So 2 absorption, 1 reflection, but the reflection not considered, the one transmitted last 1 minus alpha. Okay.
So E of the fat then times with E of the muscle times with the 1 minus alpha.
Yeah. Alpha should.
Why is it 1 minus alpha, sir, again? Because
if you never take 1 minus alpha, you take alpha means you're considering the I1, which is reflected.
Oh, okay.
You want the transmitter, so 1 minus alpha.
Then the other one, sir, is beside the 1 minus alpha is what, sir?
1 minus alpha is the absorption in the muscle. This one is absorption.
Oh, in the muscle region.
This is the absorption in the muscle. This is the transmitted in the boundary, fat and muscle. Okay.
Oh, so it's like that, na, sir.
So the wording not clear.
Yeah.
The wording look like what they say. The wording they said. Yeah. Sorry. That determine the fraction of intensity entering the layer of fat. Determine the fraction of the intensity entering the layer of fat that is transmitted through the layer of muscle. And the wording is not that clear. They must put a fraction form, reaching the surface of the end of the muscle and the initial part. Wording. Okay. Any other question?
Sir, 8C1, sir.
8C1.
Yes.
8C1. Oh, this one, 8C1. Oh, nuclear.
I don't know how to, actually the units are the problem here, sir. I can somewhat get the answer, but I don't know the unit conversion. That's the problem for me.
Conversion. The aluminium is density is this, assuming there is one free electron available, carry charge per atom of aluminium. Show that the number of charge carrier per unit volume of aluminium is this. Or per unit volume. So per unit volume. Yeah. So this, you know the density already. Density. Mass over volume. You need to find how much of atom in 1 meter cube. You need to find.
We need to get the moles, sir.
You see, 2.7 gram is 1 centimeter cube of volume. How much
Yes.
gram for 1 meter cube? Find that first. So, what do you do?
Times by 10 power negative 3 and negative 6, sorry.
Times by 10 power of negative 6.
6.
6 gram, right? Okay.
Yes.
It's the number, the weight, the mass. Change this gram to
So
kilogram.
negative 6.
Going to be negative 6. Going to be 6.
Negative 6.
Going to be 6, right? 2.7 times 10 power 6. Divide by 10 power. Correct?
Isn't it like cm cube to meter cube we times with 10 power negative 6, sir?
No. 1 centimeter cube, you have 2.7 gram. 1 meter cube,
Yes.
you got how many gram?
Because cm to meter we divide by 100, so cube means 10 power negative, isn't it?
You see, 1 centimeter cube more mass or 1 meter cube more mass? 1 meter cube more mass, right?
That's why I got confused, I think.
You see, 1 centimeter cube, a small volume, the mass is 2.7.
Yeah.
If I go 1 meter cube, how much is the mass?
Yeah.
How much is the mass? So use ratio. How much the mass here? So 1 meter cube divided by 1 centimeter cube times 2.7. You will get 2.7 times 10 power of 6 gram. So in 1 meter cube, you have how much of gram? This much of gram. Okay. So this much of gram, how many mole?
Divide by
1 mole, how much?
27.
1 mole is 27. So this is how many mole? So this is 1 times 10 power of 6 mole, right?
2.7 times 10 power 6 divide 27.
27.
So it's 1 times 10 power 5 moles.
1 times 10 power 5 moles. This is how many atom? Times 6 Avogadro. The answer you get is the number of charge carriers per meter cube.
Oh yeah, sir. Yeah. I get the answer now.
Okay.
Because usually, sir, like when we are doing like in ideal gas questions, like they give us a volume of the ideal gas as centimeter cube, and we usually used to times it with 10 power negative 6. But here is 10 power 6. That's what I got like confused a bit.
No. That one is centimeter cube. You want to convert to meter cube. This one we find ratio.
Yes.
1 centimeter cube, this much of gram. 1 meter cube, how many grams? So this ratio, this is not calculation.
Oh, so this what I can do is like 1 meter is like 100 centimeters. So 1 meter cube is like 1 times 10 power 6 centimeters cube. So I just times it with 2.7. Yeah, 2.7 times 10 power 6 grams, sir. Correct.
Any other question?
Besides that, 10 part B1, sir.
10 part B1. 10 part B1. Oh, open. B1. This one, eh?
B1.
Determine the temperature at which light emitting diode switches on or off. Determine the temperature at which the light emitting diode switch on or off. Light emitting diode. Oh, this one. Okay. So when it chances to on or off, chances to on or off is depend to they asking indirectly they asking is it going to be on or off? It happens when these two are like same. They're asking when these two input become same. That's the question.
How, sir? Like, how do we?
Because when they become same, a little higher on the negative, it become minus. When a little lower in the negative, it become plus. So that's the point where you're going to switch on and off.
Yeah.
So switch on and off happens when these two input, this voltage is like the same. The critical cutting point lah. Okay. So when this
I think we didn't learn that, right, sir? Critical cutting point.
Yeah. So now you need to find at what resistance of the thermistor you'll end up getting the same voltage. It's a potential divider. See, the voltage, the V positive is the same as voltage used by 1.2 or 1.5.
1. So here it's connected the 1.5, sir.
The V positive is
V positive. Oh, it should be
1.2, right?
Why is it 1.2?
1.2 down. 1.2 kilo, right?
So not clear, sir. That part was not so clear, sir.
Oh, the image is not clear.
No. I mean, like your voice was breaking.
For any potential divider, the voltage input to the op-amp is same as the voltage lower resistance or higher resistance. Lower resistance or upper resistance. The lower resistance,
Lower resistance.
Lower resistance. Let's say this is used 1 volt means the voltage here will be 2 volt. So the voltage going
at the junction it will be 2 volts, correct?
So the voltage V positive is same as the voltage used up by the lower resistance.
1.2.
1.2. Right. Okay, so we go to the potential divider. So the voltage of 1.2, the voltage at 1.2 must be same as voltage of 1.76, right?
Yes.
This is a potentiometer. Last time this circuit is similar as like this. Like you have two resistance here, you have another resistance here, and you have another resistance here, another resistance here. You want the voltage to be 0. You want the voltage 1 and 2 become same. Or you want the voltage 3 and 4 to become same. You want a V3 same as V4.
Actually, the PD across them is 0, sir.
So what do you do? This is the potentiometer. R1 over, you follow this formula, R1 over what? R1 over R3 must be equals to R2 over
R2. R4.
Right.
So R1 over R3, sir. Why like?
The ratio of the resistance law. So
okay.
R1, R3 is here. This 1.5 is your R1. Okay.
Yeah.
Your 1.2 is like your
R3.
R2. R3, sorry.
R2,
R3, yeah. And
R3.
resistance of the thermistor is
R2.
R2. Then this one is R4.
Oh,
So
so
find
it'll be
R2.
like
Find R2.
R1 over R3
5.
times R4.
R2.
So the resistance should be 2.2 kilo ohms.
2.2 kilo ohms. So 2.2 kilo ohms. So what do you want?
Yeah.
What the question?
The temperature at which.
So you know the resistance of the thermistor already, right?
Yes.
So then go to the graph and check the temperature.
So it'll be like, so can.
Yeah. Let me. So check the temperature. Just now, how many resistors you get? 2 point something. You go straight and cut. Go to the temperature down.
Yeah.
You get the answer. How much
So
is
it should be like somewhere like 14 degrees Celsius. Is that the answer, sir? 14 like that, is that rich?
Let me check.
Yeah, sure.
10.
Yes, sir. 10B, pardon.
14.
Yes.
14.
14.
So it's 14. So V negative must be same as V positive.
Yes, sir, I have a question. Why is R1 of, oh, you want it to have same voltage? That's the cutting line between negative and positive.
Yeah. That's the point where
So
you can.
why did you actually use ratio of resistors, sir?
Because ratio of resistance is the same as ratio of the voltage.
Yeah.
Ratio of the voltage.
Yes.
The voltage at 1.5, you see, is the voltage of 1.5 same as the voltage of R total. The voltage at these two junctions will be the same. So the input here will be the same. So we have to go to the what do you call the Wheatstone bridge style. I think last time when I teach AS, I told you Wheatstone bridge, like for resistance. R1 over R3 equals to R2 over R4. That to be useful. Okay.
Yes, sir.
Any other question?
The same part, but the second question, like.
Still, and explain whether the thermistor is above or below the temperature calculated LED to emit light. Oh, now you tell. Now they're asking. Explain whether the thermistor above or below the temperature calculated one for LED to light up. Oh, okay. You see, now the LED to light up. The cutting point is 14 degrees Celsius. Okay.
Yes.
Tell me, is it going to be 15 degrees Celsius or 13 degrees Celsius? The LED will light up. For LED to light up, the output must be positive or negative.
Positive.
You see here, must be negative.
Huh?
Correct. You see, LED is forward bias upwards, you know.
Yeah.
Oh,
yeah, positive cannot go because it has blocked.
If this is positive, current cannot flow. It won't light up.
Oh.
So
yeah.
you should know that.
It's like reverse bias, but forward bias for the negative terminal.
So output must be negative. So output to be negative, V negative.
RT must be bigger.
This V negative must be greater than V positive.
Greater. So should the temperature be lesser?
For the V negative to be big, this resistance, RT resistance must be get lower.
Lower. So the temperature must be lower.
Temperature must be
so
lower.
RT resistance must be lower, sir.
Because if it's lower resistance, it's higher voltage one.
If RT lower resistance means 1.76 use high voltage, so V negative become big.
So why negative? But negative is connected after R1, sir. Like, always we see the R1, sir.
Yeah, because V negative is the voltage used by the lower resistance. So upper resistance must get smaller, so that the lower resistance get big. Lower voltage get big. So V negative get bigger.
So the temperature has to.
So to get lower resistance, check the graph. To get a lower resistance, the temperature need to be rise.
To get a lower resistance, the temperature should increase, sir. Then?
Increase.
Okay.
Any other question?
This is I think maybe this question, okay, so maybe we can like do once more, like try like how since we know that the LED, for it to light up, it needs to have a negative input, correct?
Yeah. So the
So
LED
actually,
light up,
how
it must be a
like
negative.
in the initially, how do we actually determine which polarity is used by which resistor? So is there a way like?
Which polarity uses which resistor? No, you see, the negative is connected to the first potential divider. Okay.
Yes.
So V negative is dependent to this potential divider. The V negative is actually same as this voltage. This is a V negative. Okay.
Oh, why says that? Because it's connected after the thermistor.
Yeah, the
So
voltage.
we need to consider the voltage which is left in that system.
Yeah.
Oh, okay.
Remember, always the voltage input is the voltage used by the lower resistor. That's why that's how it works. Yeah. So to make V negative big, the lower voltage must get big. To make lower resistance get big, either you raise this resistance, the lower resistance, or you lower the upper resistance.
Resistance.
So here lower resistance is big, so upper resistance is reduced.
So yeah,
Okay.
true. So because they say state and explain, like, so how do we like put it across in a nice sentence, like, like,
so you see,
how do we
output,
like the question? Where's the question, sir? Like,
the question.
Question.
Still and explain 3 marks. And explain thermistor above, below, or temperature. So first you have to tell the output must be negative. You must say
Yes.
the output must be negative so that the LED is forward bias. LED is forward bias. For the LED to be forward bias, output must be negative. For the output to be negative, V negative must be bigger than V positive.
V negative has to be greater than V positive.
For the V negative, so V negative, for the V negative bigger than V positive, voltage across thermistor must get lower. Therefore, resistance must get lower. So temperature need to be raised.
So sir, like V negative is the one which we need to increase.
Yeah.
So like V negative. So can we go back to the diagram, sir? Like, okay. So the V negative is connected to the first potential. V positive is connected to second. Also, like we reduce the resistance above the positive one is the resistance above, sir.
Yeah.
So every time we remember V negative is the one which is down.
Yeah, always the down voltage is the V negative. Same thing goes for the V positive. So the down resistance voltage is the V positive. Okay.
So like, now the thing
the
is that
bottom one is the one that determines the voltage.
Voltage input. Yeah. Actually, of course, both resistors are potential divider. One. The first resistor will take up some voltage. The remaining one is not going into the op-amp. The top resistance. The top resistance takes some voltage. Okay. The top resistance will take some voltage.
Okay.
Then the balance one is the one sent to the op-amp.
Okay.
So
what about the bottom one?
Yeah. See, let's say top one take 1 volt. Let's say 3 volt. So the bottom one will take 2 volt. The one sending to the op-amp also 2 volt.
2 volt.
That's why.
So like.
So that's why we calculate directly from the bottom one.
That's why you take the bottom one.
But one question, V positive also is the one which the V positive is the voltage taken by the 1.2 kilo ohms. And V negative is the voltage taken by the 1.76 kilo ohms, right, sir?
Yeah.
So both of them are influenced by both V positive and V negative is influenced by the resistors which are down, the 1.2 and 1.76. Am I right?
The voltage input, the V positive, is influenced by, it's not only influenced by this resistor, also influenced by the top resistor, right? Because they are sharing the voltage one, correct? The voltage input is affected by both of them, right? But the voltage going into the op amp is the exactly voltage you start by the lower resistance. That's it.
Lower resistance.
But the voltage of the lower resistance, is it affected by the upper resistance? Affected, right?
No. It's affected, yes.
Because they are sharing the voltage one. But the voltage going into the op amp is the voltage exactly same as the voltage of the lower resistance. But the voltage of the lower resistance is affected by the both resistor, right?
Yes, sir.
The ratio.
So, like, how do we actually how do we actually make sure that V plus is lesser, sir, by V plus, like?
How to make V plus lesser?
Because we said that V minus has to be greater in this case, right, sir?
Yeah.
So like V plus has to be smaller. So how do we actually make sure that V plus is going to be smaller, sir?
No. You see here, you only control one. Here V plus they fixed. V plus they already fixed. They never changed. V plus the resistor is same. Resistor was fixed. So V plus input going to be fixed. So V plus no change.
Okay.
V plus no change. You know the output, the output amplification there. So V plus was fixed. V minus has been manipulated by using this was fixed. Okay. V minus has been manipulated by sensor. That's it.
Oh, so actually what they are trying to say now, V plus is fixed. Now to make sure that V minus is going to be greater, what we have to do is we reduce the resistance of the thermistor, and that will make sure that the V minus will be a much larger value, sir. Is that so?
Yeah, like that.
Oh, okay. Because I thought, how come V plus also is like...
V plus is fixed, right? Because the fixed resistor.
Fixed resistor, okay.
If they put the sensor at V plus, then V plus going to change, V negative going to be fixed.
Okay, sir. Got it.
Any other questions?
11C, sir. Sir, but maybe before that, the two questions before 11C, sir. Can we like just some clarifications on that as well?
Okay. Which one?
Okay, sir. They said
which question?
11B, sir.
Oh, 11B, okay.
Yeah.
Oh, that's the solenoid and a switch coil. Okay. So which part you got a problem?
B1. 1 and... No, sir, not really a problem, but just to clarify, sir, maybe 1 and 2, sir.
There's no electromotive force induced in coil C. Or which time to...
So electromotive force means there's a change in current, right, sir?
Electromotive force means no voltage in the C.
So that means T1 and T3, because the gradient there is 0, sir.
Yeah.
Oh.
Gradient 0 means gradient 0. No.
No, at the maximum point.
The maximum point. Current where?
Current is here, sir, in the graph.
Yeah, the current they show is which current? The variation of time current solenoid solenoid S. Oh, current here. You see current here constant means that there will be no voltage induced in the C, correct?
Yeah.
S must have a constant current. At which region current was constant? Current was constant for a while. Yeah, at the peak T1 and T2. Current was constant for a while. Yeah, T1 and T2, T1 and T3.
T1 and T3, yeah.
Yeah.
And they said they
we will be continuing if it stops. We'll be continuing next paper if we finish this. We continue do the next paper also. Next paper will be what?
May, June 19.
May, June 41, is it?
41, yes.
41, the next paper after we done this. Okay, which question now?
When we will discuss that, sir?
Do you done that paper already?
No, not yet.
After we done, maybe
Monday?
Monday.
May, June? Wait, May, June 1941?
May, June
Yeah.
1941, yeah. We go down from 19.
Okay. And sir.
Yeah.
Can we do the class like, because we have another, like our chemistry lecturer, so what she does is she makes us finish it, and then she will go like question by question, like she will do it together with us.
Yeah.
So because some parts our answer are correct with the mark scheme, but then we don't actually understand how we got to that, or maybe some parts where we could have made a better answer, she says. So maybe
we're going to go through all the questions.
Yeah, like one by one. So, I mean, it's a bit slower. It takes us like 2 to 3 classes to finish one whole paper for. But like
that thing, you see, good and bad. But that way, like you'll be going to spend some questions which you already know. So it's going to be wasting time, right?
Yeah, I mean, like we just like what she does is we go through and then like she goes through with us the question. She tells us roughly how we do it, and then she just calls one of two of us out to just like, okay, how you do it? If you have difficulty, because sometimes we get the answer but we don't really understand, and then she just explains it and like, okay, then next question.
And
so,
sometimes,
like, okay,
what?
Okay, can no problem. So it's up to you. So you want to go one by one?
Yeah, because like even if we do like now, like we know like only those like we have problems that we think there are problems, then we understand more. But then what about the rest which we don't know we actually have problem, right?
So the question you got correct. If you don't understand, you can bring up here, so we can discuss again, right? Let's say you got some answers correct, but you still don't understand. So you can ask here back, so we can discuss what. Right? So it's up to you. You want to go one by one also can, because you are the main one. Okay. If majority want to go just the questions you don't understand, or you want to go the entire paper. I believe entire paper like quite slow. You can't go through much questions.
Okay. Now, my sir, we discuss and then we confirm with you. Is that okay?
Yeah, can.
Yeah. Thank you, sir.
It's individual one. You got a problem with the first question, although you got a correct answer, you can still raise up. We can discuss.
Yeah.
Okay. So yeah,
so
the T1 and should be T1 and T3.
T1 and T3, right, sir?
Yeah, because current is constant for a short while.
Yeah. So then the next question, they said induced EMF is a maximum, but with opposite polarities. So it should be T2 and T4, right, sir?
The voltage maximum happens because rate of change of flux is maximum. Rate of change of flux maximum happens when the current change very fast. That means
so T2,
D2 and T4.
Because opposite polarities.
Yeah, highest gradients above. Yeah.
So now it comes to the question C, sir. We found BAN over T.
Yeah.
Right, sir. But they times with 2, sir, in the mark scheme. I don't understand why. There is a keyword, sir.
Yeah, 2. Because
because reversed. Okay, I understand because of the word reversed, but why actually